Hi everyone, welcome to Geometry Chapter 2 Day 1. Today we're going to be covering complementary, supplementary, and vertical angles, as well as angles formed by transversals, which are formed from parallel lines. So let's get started. Our learning targets today are learning how to name angles, supplementary, complementary, and vertical angles. Also learning transversals and how they intersect parallel lines, corresponding angles. Specifically, we're going to be targeting them. Angle relationships and naming parts of shapes. These are two videos that CPM gave out that basically correlate with what we're teaching today. So if you have a chance, I would definitely recommend watching both of those videos. So a little warm up here based on some properties that we're going to be reviewing. First of all, whatever the best reason for these statements are. So if AB is equal to CD, and then CD is equal to AB. And for that reason, that's called the symmetric, and that's a property, symmetric property and of equality. And mostly because what we're doing is we're saying AB is symmetric to, AB equals CD. I can flip those around and say CD is equal to AB. Now, there's another one that is, sometimes people get confused with this property, the symmetric property of equality is the reflexive property. And with this property, that's just saying that I could have said that AB is equal to itself. And so if you see something like that, that's the reflexive property, if you have the exact same thing equal to the exact same thing. But if you're flipping them and they're flipping them around like that, that's symmetry. That's symmetric, property of equality. For this problem right here, it says if AB is 12, so they're giving a value to that, then they're saying that AB minus 5 is equal to 7. And so that's just substitution. If M is in between A and B, so let's draw that. So here's A, here's B, and M is in between. And it didn't say in the middle, didn't say right anywhere specific. It just said in between. So we'll just put M right here. And so what they're saying is that this little length right here, AM, plus this length here, which says MB, is equal to the whole length AB. And that's true. And we call that the segment addition postulate. Okay? So let's write that down. That's called the segment addition postulate. Oops. Okay, and lastly, oh boy, this is giving me issues. Postulate. Okay, the last one says if AM is equal to 3, okay, so we'll give this a value, and AM plus MB is equal to the whole length, then 3 plus MB is equal to AB. And again, we're substituting, so that's called the substitution property, in this case of equality. All right, so that was our warm-up. So let's get to special angle pairs. Now, the first kind of angle pair I want to talk about is called an adjacent pair of angles. Adjacent means next to. It means they share a common ray. So what that means is if I'm here standing at this angle here, which is angle AEB, right? And you call it like this. You say A, and then E. E is the vertex, and then you've got angle B or AEB. So for this angle here, something adjacent to that might be BEC. See how it's next to? And this is my common ray, BE. So if BE, and I write it like that with a ray at the end, if BE is my common ray, then angle 1 and angle 2 are what we call adjacent. Now, also, I could say this, because if I'm looking at EC right there, right? If I'm looking at ray, EC, then what I'm seeing is that this angle here would be adjacent to that angle because they share that common ray. So if two angles share a common ray, meaning they're right next to each other, but they share a common ray, we call those adjacent. Now, a linear pair is a pair of angles whose non-common sides are what? A pair of blank angles whose non-common sides are what? So if you think about this, first of all, linear pair is two angles, okay? And when you're thinking about this right here, the non-common sides right here. So we've got this angle here and this angle here. See that there? It's a linear pair. They make a line. So not only do they make a line, but they also add up to be 180, which means that they're supplementary. And so this is a pair of two angles, non-common sides. So so this side is common. So if hopefully you're remembering what we just went over with adjacent, so they're also adjacent, okay? And because they're adjacent, right, and because they create a straight line, the non-common sides are straight angles. So this is a straight angle right here, okay? And then lastly, the linear pair theorem basically says if you have two angles, like this angle here, we'll call it 1, and this angle here 2, which are adjacent, and they do, the non-common sides are straight angles. If two angles form a linear pair, then they're supplementary, meaning that I could say the measure of angle 1 plus the measure of angle 2 equal 180 degrees. And that's what that means by supplementary. Two angles that add up to be 180 degrees. Then they're supplementary. Complementary angles are two angles whose measure has a sum of 90 degrees. So, and we usually put a little box here to denote that that's a 90-degree angle. So in this case, you could say that angle XOY, remember O being in the middle, that goes in the middle of my angle. So I could say XOY and angle YOZ, so YOZ, I can say that those angles are complementary. They're complementary because they add up to be 90 degrees. So 35 and 55 degrees, if I add those up, right, 5, 6, 7, 8, 9, they add up to be 90 degrees. I could say that one of these angles is a complement of the other. So, I mean, but basically what you need to know is that if I said the measure of angle XOY plus the measure of angle YOZ is equal to 90 degrees, that means that they are complementary, okay? With complementary and supplementary angles, another thing that, I'm going to go back to the supplementary angle or talk about that. Another thing that you are going to see is something like, there's going to be like a word problem. Meaning, if I said that I had an angle like this, okay, and I said that these two angles, this is 90 degrees here, and this is X, and you know that X plus whatever this value equals 90, then what would this angle be represented? And hopefully you would think that that would be, well, it's 90 minus whatever that X value is, right? So that's how we do that. So whenever something says it's a complement, this is the value that I'm looking at right here. So if I said I have an angle, then I'm going to say that's X. But if I said the complement, what is the complement, okay, then I'm going to say 90 minus X. Likewise, if I was talking about supplementary angles, right, supplementary angles, if I had a straight line and I said, okay, here's my angle, X, then what's this angle here? Well, that angle is going to be 180 minus whatever X is. Because if this is 20, right, and all the way around is 180, then this part here is going to be 180 minus 20, which is 160. Okay, so if I say, what's the supplement? Anytime I ask you, what's the supplement, you're going to say it's 180 minus X. If I ask you what's the complement, you're going to say it's 90 minus X. So that's what I'm actually looking for when I ask you what's the complement and what's the supplement. Supplementary angles are two angles that have a sum of 180 degrees. So meaning one's 120 plus 60 is equal to 180 degrees. So in this case, angle P and angle Q are supplementary, and be careful because notice that these aren't a linear pair, right? I mean, they're not. If you have a linear pair, then you have a pair of angles that add up to be 180, but be careful with that, because I'm asking you, are they actually also connected, right? I know that could be 120 and that can be 60, but see how these are connected here and these are not? These are adjacent, right? And these are not. They're just a pair of angles, right? That form that create supplementary angles that are supplementary. Whereas this is a linear pair of angles that are supplementary. I mean, they both add up to be 180, so you could think of it both like that. I want you to find, so in these cases, you're going to use your calculator. They're complementary and supplementary practices, or just angle practices in general. Keep in mind, this is a straight line, and straight lines have a degree measure of 180 degrees. So if I tell you that part of that angle right here is 152, right, then I can say, well, 180 minus 152, and that's going to give me 28. So I'm going to go 180 minus 152. That gives me 28 degrees. And so that means that this angle, so you're going to say it like this: the measure of angle PNM, PNM equals 28 degrees. And that's how you would write it. You also, though, can say the measure of angle MNP equals 28 degrees. Either way, what you can't do is you can't say angle N, because angle N is just right here. That's just a point. So we don't know if we're talking about this angle here or this angle here, right? Or the entire angle. So you can't just say that one angle unless it's just by itself. For this problem here, this is just a congruent practice, meaning if you notice this little slash here and here, that's saying that those two angles are congruent. It's saying that angle KGF is congruent to angle KGF is congruent to FGH. So FGH. And by congruent, what I'm saying is that they're the same value. So that means that they're equal. So I'm going to say 4x minus 5 is equal to 3x add 2. I'm going to solve for x because I want to try to find out what my directions say, which is find an angle. So I'm going to subtract 3x from both sides. So if I subtract 3x from both sides, I'm going to get x on this side minus 5 equals 2. And then I'm going to add 5 to both sides, and I'm going to get x is equal to 7. So I found x, but x is not my answer. Okay, I'm not even going to box that up because the question that they asked me is way up here, and that question said find FGH. So FGH, they want this angle here. And so that angle is 3x plus 2. So that means that if x is 7, that goes in here. So I'm going to go 3 times 7, add 2. So 3 times 7 is 21. 21 plus 2 is 23 degrees. So that means that when I write my answer, I'm going to say the measure of angle FGH is equal to 23 degrees. And then that's what you can box up. Okay? The next question, more practice, is this. This is a right angle. They tell me that, which means that they're complementary. It also means that they add up to be 90 degrees. So I would say 2x minus 4 plus, so it's going to be this little angle plus this little angle equals the big angle. We call that the angle addition postulate, like we were talking about on that first slide. When you add these together, so we have x plus 7, that's going to equal 90 degrees. So 2x plus 1x, so that's 3x, minus 4 plus 7 is add 3, is equal to 90. Subtract 3 from both sides. 3x is equal to 87. And then what I'm going to do is I'm going to divide by 3. So x is equal to 87 divided by 3. So what is that? 87 divided by 3, it is 29. 87 divided by 3, is that right? 29, so that's x. Okay, hold everything. That's x. But is that what I asked you for? So go back to the beginning, and they're asking me to find angle DBC. So D is here, so DBC. They want that angle right here. They don't want x. They don't want the whole angle. They want that little part. So that little part is x plus 7, right? So x plus 7. So if x is 29, that goes right here. So we're going to go 29, add 7, and what is that? 36? So that means that, and this is how you write it, the measure of angle DBC equals 36 degrees. And that's what you can box up. This question over here says the measure of angle LPQ. Oh, that's what we're trying to find. LPQ. Where is that? LPQ. They want this angle right here. And it looks like that angle is actually x plus 28. So that means I have to find x. Okay, then it says that the measure, and the measure of LPN. So LPN. So they also want this angle here. So what do we know? Okay, so let me erase this, see what we actually know. Looks like we know that this is a line. And what I know about lines is that they add up to be 180. And so that angle right here plus this angle right here adds up to be 180. So watch. X plus 28 degrees is equal to 180 degrees. So what we have now is 2x plus 28 is equal to 180 degrees. So I want you to take 180 and I want you to subtract 28. And so when I subtract 28, because we're just solving the problem, I'm going to get 152. So I get 2x equals 152. Now, to get x by itself, I need to divide by this 2. So when I divide both sides by 2, I get x is equal to 152, right, divided by 2. And what is that going to give me? I get 76. So that's x. Now, again, that's not my answer, right? That's just what x is. So, I mean, like, you can box it up if it makes you happy. Obviously, it made me happy to box that up, but it's not required because that's not actually what the question says. The question says, well, yes, we have to find x, but we also have to find these two angles, okay? So let's plug our answer 76 into what we know. We know that this angle right here is going to be 76 plus 28. So you've got 76, add 28, and what is that, 104? Yeah, that looks like 104. So this is 104. Now keep in mind that this is a straight line. So if I took 104 and I subtracted that from 180, right, I should get this rest of the angle here, which is 76. And I think that's it. And the way you would write that, just to note, you have to write it out the right way. So the measure of angle LPQ, that's this angle right here, is equal to 104. And then the measure of angle LPN, so LPN, which is this angle right here, is equal to 76 degrees. So make sure that you write those out correctly. And these are definitely multi-step problems. So you do have to try them. And then the more you try these, the more you're going to, the better you are going to get at them. This brings us to something called vertical angles. And I want to go back to this value here. I want to remind you that when I had this right here, right? Okay, and I said that angle X was 76, which was here, right? And then we figured out that this was, 104? And then we said, well, this also was 76. You see these angles right here that are like that? They kind of make a bow tie. Those are what we call vertical angles, okay? And this is what I'm talking about on the other page. They're angles that kind of they cross, and they're these angles here. They make a bow tie. Vertical angles share the same vertex, meaning here's the vertex. And what it means is that whatever this angle is right here, this is also congruent. They're exactly the same values. So in that other example, that was 76, as well as that one was 76. So whatever that side is equal to, that also is equal to. So when you're trying to find x, right, you know that because they're like that, and they got that right across from each other, like those bow tie angles, these are congruent. So then what that means is I can go 2x is equal to 60, divide by 2, x equals 30. So I found x, but I did find x, check, because it did say find x, but it also said find all of the angles. So not only did I find x, but in order to find the angles, I know that if that's 60, that's also 60 degrees, right? Okay, we know that. But keep in mind that this also is a straight line, right? Anytime you see a straight line, that's 180 degrees. So in order to find this angle here, I'm going to go 180 minus 60, which is 120 degrees. And again, though, right, bow tie angles here, which are vertical angles, that angle here is congruent to this angle here, which means that's also 120. So those are vertical angles. So far we've talked about corresponding angles, we've talked about vertical angles, and we've talked about supplementary angles. I forgot almost that we were also talking about adjacent angles. And remember, adjacent angles share a common ray. So that would be my ray. And see how this angle here and this angle here, they share that ray. Excuse me. And then we've got a linear pair, which is a pair of adjacent, here's my adjacent, angles that share opposite rays also, but they also form a 90 degree. They form a 180 degree angle. Okay, and complementary angles, oh, we didn't talk about corresponding, we talked about complementary angles, and those are two angles that add up to be 90 degrees, and supplementary angles are two angles that add up to be 180. So talking about these angles, right, and adjacent angles, if you notice that angle 2 and angle 1 actually share the same ray, M, right here, right? And that, so not only are they what we call perpendicular because we show that they're right angles, but they are also adjacent right angles because they're right next to each other. See how they share that same ray in the middle? So one thing to consider is this, that once you have one right angle, right, which is 90 degrees, this angle has to be 90 degrees because that's a line. And then if you turn this way, right, if this is 90, that has to be 90 because that makes a line 90 and 90. And then if you're here and you're like, well, what's this angle down here? That also has to be 90 because 180 minus 90 is 90. So if you have one right angle, you have four right angles automatically. Theorems relating to perpendicular lines. This perpendicular line theorem that says if you have two lines that are perpendicular, that means they show a right angle, then they form congruent adjacent angles. That means that they're both 90 degrees. And they're adjacent because they're right next to each other. And what a converse means, if you look down below, it says the converse, if two lines form congruent adjacent angles, then the lines are perpendicular. So the converse is this, right? It's like taking the hypothesis and the conclusion and flipping them like that and putting the conclusion first and the hypothesis second. That's what a converse does. And sometimes the converse isn't going to make sense, and sometimes it is. Meaning, if you say, if it's Sunday, then USC will win. Or then you could flip it, and you could say, well, if USC wins, then it was Sunday. So sometimes it doesn't make sense if you flip it, and sometimes it doesn't make sense if you say it wrong the first time. Okay. So the last theorem relating to perpendicular lines is this. If the exterior sides of two adjacent acute angles, so this is my exterior side here and here. Exterior means on the outside, right? Oops, that should be over here. Hold on. Exterior meaning on the outside, okay? So if I've got my exterior sides of two adjacent acute angles, these are adjacent, right? If they are perpendicular, right, which means that they're 100, then that means that they're 90 degrees. Then those angles inside, so that means that angle 3 and angle 4 are then what we call complementary because they're part of exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. And what that means is that if AB, this is this line, is perpendicular to this line right here, right, then the measure of angle 3 plus the angle of the measure of angle 4 is equal to 90 degrees. That's easy. Okay, so these are just some theorems basically saying, hey, here's a shape on the right. What can you say about any of these, okay? So if 4 is equal to 5, now look at down here. So 4 equals 5. I'm going to go with those are vertical angles, right? Okay, that's done. And actually, what I like about this, let's see if I can get all of these together. What I want to say, let's see. What I want to do for all of these, just to make it easier to see, is I want to make those red. Okay, so that when we do these, so it'll be easier to see. So we know that if these are equal to each other, then those are vertical angles. So 4 equals 5. If, let's see, which one do we want to do? If DC is here. If DC is perpendicular to DA, which means that would be a right angle down here, that would mean that then 7 and 8 are complementary. So what allows you to say that? Okay, that is going to be if the exterior sides, which are these two sides here, of two acute adjacent angles are perpendicular, then the angles are complementary. And so that would be this one. That's the one we just talked about, okay? If AB is perpendicular to BC, so if these two are perpendicular, okay, then ABC is a right angle. Well, that's just definition of perpendicular lines that say perpendicular lines form right angles. Let's see, if the angle ADC is a right angle, if it's right, then the angle is equal to 90 degrees. So if this is a right angle, then it has a measure of 90 degrees. That's just the definition of a right angle. Okay, so if 4 and 6, so here's 4 and 6, they are, I think that's 4 and 6, yeah. Then AC, what does it say? If 4 is equal to 6, well, if they're equal, then they're both 90 degrees, right? Then the angles are perpendicular. And so that's that converse of this value here, of the perpendicular line theorem, okay? And then, where are we at now? If 7 and 8 are complementary, then the complementary angles, 7 and 8, add up to be 90 degrees. That's definition of complementary angles. And then if these are two perpendicular lines, then we're going to say then they form the congruent adjacent angles, and that's the perpendicular line theorem. Okay, more practice time. So we are going to get to using the diagrams to figure out what we know. We know this is 90 degrees because it's got a right angle there. We also know that this distance from here all the way to here is 180. So you have a choice. You can either say this plus this equals 90, or you can say this plus this equals 180 degrees. So however you want to say that, I'm going to do that. So we're going to go 7 minus x plus 90 degrees plus 3 minus 9x adds up to be 180 degrees. Now, what I'm going to do first is I'm going to take out this 90 degrees. So I'm going to subtract 90 degrees from both sides, and I'm going to get 7 minus x plus 3 minus 9x equals 90 degrees, okay? So then I'm going to combine my x's. So it looks like I have negative x and negative 9, which is negative 10x. And then 7 plus 3 is plus 10 equals 90. I'm going to subtract, let's see, I'm going to subtract 10 from both sides. And it looks like if I subtract 10 from both sides, I'm going to get, what is that, 80? And then I get negative 10x is equal to 80. So x is equal to negative 8. And so if x is equal to negative 8, let's plug this back in and see what our angles are going to be. So this is x is equal to negative 8. So coming back up to the top, I'm going to erase this, and let's see what happens. X is negative 8. So that means that 7 minus negative 8, and we know that's 90. 7 minus negative 8 is actually 7 plus 8, which is 15, which means that's 15 degrees. Well, now I actually don't even have to do this right side, do I? Because I can go 90 plus 15, right? And you get 105, and take that away from 180. And what is that, 75? So I know that this is 75 degrees. But yes, I could have plugged in the 8 and gone 3 minus 9 times 8. Well, 9 times 8 is minus negative 8. That makes 72. So 72 plus 3 is 75. So that gives me all of the different angles, okay? For this problem here on the right, we don't know the vertical angles which go across, but what we do know is that these two angles right here add up to they make a line. So 5x minus 8 plus 13x plus 8 equals 180 degrees, okay? So we have 13, add your x's together, so 13 plus 5 is 18x. And then I've got negative 8 plus 8, that's 0, that goes away. And then I have 18x equals 180. And then if I divide both sides by 18, I get x equals 180 divided by 18, which is just 10. And then if, depending on what they're asking me, if they're asking me for a variable, which they did, then x is 10. And the other problem, x is negative 8. But if they're asking me what's the value of the angle, keep in mind that I do need to plug those in. Meaning I would say if x is 10, I'd say 13 times 10, which is 130, add 8. So this angle would be 138. And then this angle would be 5 times 10, which is 50. Subtract 8. So 50 minus 8 would be 42. So, and of course, if these are vertical angles, that also would be 138. And over here would be 42. For these problems here, again, what we know is that this angle plus this angle plus this angle is 180 degrees. That's 90. So therefore, this angle plus this angle are going to add up to be 90. So we're going to say 2x plus 3x plus 15 equals 90. I get 5x plus 15 equals 90. I'm going to subtract 15 from both sides. And then when I do that, borrow 875 equals 5x, and then divide both sides by 5, and then I get x equals 15. And so that's what x equals. And all they're asking me to do is solve for the variable, but I do want to make it very clear that that's not all I'm going to ask you on the test. What I'm going to ask you is to take x equals 15 and plug that back into for these equations. So we know this is 90 degrees, right? We know that this is 2 times x because it says 2x. So what's 2 times 15? That's 30. And then these are vertical angles, so that's also 30, right? Which means that if this is right, based on this being right because they're adjacent right because they're perpendicular, I can't see that side here, 3. Then this angle here would be 60 degrees, right? Because 90 minus 30 is 60. So keep that in mind. Even though I'm asking you just for the variable, I'm also going to be asking you for the angles. In this case here, this one's kind of fun actually. This is a right angle. These two are right angles. So 40 plus 50 adds up to be 90, right? Because the complement is 90 minus 40, or 90 minus, yeah, right? That value, so that's 50. Likewise, these two angles right here are also 90, so this x is 50. And then these angles are perpendicular, which means that angle is 40. So we've got x is equal to 50, y is equal to 50 degrees, and z is equal to 40 degrees. Cool. So now we're moving on to parallel lines. And parallel lines, yeah, sad that they'll never meet, okay? So just talking about parallel lines, you've got different kinds of lines, okay? We have 3 different kinds of lines, okay? We've got intersecting lines. Now, these are lines that are in both figures, okay? So, for example, if you look at my diagram right here, these are called intersecting lines. We've got 2 planes. We call those planes. Planes going on forever and never ending. So a plane, and by the way, you need 3 points for a plane for sure, okay? This line right here that I'm giving you, see that line, is actually in the plane that goes up and down, but it's also in the plane that goes across. So you would say that those are intersecting planes. Then you've got parallel lines. Parallel lines exist inside one plane. So if you have 2 parallel lines, they have to be in a plane. So if I say, okay, this line, let's say line L is parallel, and we show a line is parallel by these arrows on it, okay? That those 2 lines are parallel. So we'll say L is parallel to M. Well, that means that those 2 lines that are parallel, they have to be in the same plane. That's important that you know that. Parallel lines have to be in the same plane, because if they're not in the same plane, then they are what we call skew. Skew means that they never intersect, which means they're parallel, but they're not in the same plane, so therefore they're technically not parallel. So if you have lines that don't intersect and are not coplanar, coplanar meaning in the same plane. So if they're not in the same plane, they're called skew. So basically, I could have a plane like that, right? And inside that plane, I have this line, and we'll call that line L. Well, that line L, there's another line down here. We'll call that M. Well, those two lines are not in the same plane. They're in the same universe, but they're not. They're in the same space, but they're not in the same plane. So therefore, we call those skew, meaning they're not parallel because they're not in the same plane. So parallel planes look like this, okay? And that means that they're never going to intersect. Then you have a line and a plane are parallel if they never intersect. So see, these will never intersect, ever. Okay, so however, I could have a plane and a line intersect if I did this. Okay, if I did my line came down through like that and then took off down here. Now they're not parallel, but they do intersect, right? See the difference between the two? These are intersecting. That's a point, it's a line and a plane intersect in a point. Whereas a plane and a line can be parallel, meaning they'll never intersect. So you can use your sticks and your arms to represent the following. So you could do that. Two intersecting lines like that. Two skew lines. So that would be like that, right? Two parallel lines. A line and a plane that are parallel. So again, a plane and a line, parallel. Two parallel planes could be like that. A plane intersecting two parallel planes. So that's a little tricky to draw, I will say that. I don't know if I could even draw it. So we've got a parallel, it says a plane intersecting two parallel planes. So, okay, so let's say that I've got two parallel planes like that, and then I've got another plane, let's see if I could draw this, I don't even know if I can, that intersects those two. Crazy. Okay, I did that kind of. And by the way, when planes intersect, they intersect in a line. When a line and a plane intersect, right? I just did that they intersect in a point. All right, so matching the terms with the given description, you guys have AE. So here's AE. Now this is a little bit tricky for sure. You've got AE is right here, and then you've got plane GH JKF. So they're talking about this bottom plane and then this line up here. Well, see how they're like this? Those look like they're parallel to me, so I'm going to go with parallel. Okay, now I'm going to erase this. Start over again. It says plane AE, use a different color, AEKF. Oh, so now they're talking about this plane right here, and plane DJHC. This is a tricky question. I will say that. This is tricky because I want you to understand that planes are never ending. So this is actually going to keep going. And this is actually going to keep going. And at some point right here, they are going to intersect. So that was a mean question. That's intersecting for sure. Okay, moving along. Oops. Next question. Okay. Question says BC. Okay, so where are we at? BCHG. So they're talking about this backside over there. And DJ. D, where's D? D. I don't see D. Maybe it's right here. Yep, okay. And DJ. So this line right here. So we've got this plane. Now, when is this line going to intersect that plane? It doesn't look like it's going to intersect, does it? Kind of looks like a plane and a line that's parallel, but are never going to intersect. And are they in the same plane, though? That's the big question. That's the big question. Are they ever going to intersect? Because if they're not going to intersect, if this plane here is never going to intersect this line, and they're not in the same plane, right? Then would you say that that was skew? Okay. So that's what I would say for this problem right here. Now for this one, AE, let's look at this. AEDCB. So we're looking at this right here. And then let's look at this right here. JK, JK, F, G, H. Okay, so two planes never going to intersect. That's going to be, those are parallel. And then, what did I say this was? Skew? Okay. All right, so now we're moving on to something called transversal. So a transversal is a line that intersects two parallel planes. So write that down. A transversal intersects two parallel lines, okay? And so a line that intersects two or more coplanar lines in two distinct points, it basically means this line, if I have this line is parallel to this line, okay? Then that means that this line right here that intersects them into two or more distinct points, that right there is what we call a transversal, okay? So this line is my transversal because it intersects those two parallel lines. Parallel lines cut by a transversal. There's my transversal. And I know that you're thinking that they're not parallel, but I'm telling you that they're parallel. So then they're parallel. I know they don't look parallel, but we're going to say they're parallel. Two parallel lines cut by a transversal right here basically give me different kinds of angles. Okay, so it's kind of important that which one's a transversal. We know that this one is a transversal. This is not a transversal. Okay, now if I say that my transversal intersects two lines, it's still a transversal. But if I say my transversal intersects two lines that are parallel, then those lines that it intersects are going to intersect in multiple angles that have different names, and we're going to talk about those. So two lines cut by a transversal is going to give us 8 angles. 2, 3, 4, 5, 6, 7, 8. So there's 8 angles. Okay? For every time a transversal cuts through two lines, I get 8 angles. Okay? All right. Now, depending on these angles, we have different names for these angles. If you think of these two lines being parallel, and they have to be parallel, then this angle in here and this angle in here are what we call alternate interior angles. Now, we call them alternate because it's on both sides of the line, and on both sides of the transversal. And we call them interior angles because if these are my two lines, right, that my transversal is cutting through, those are my two lines, then that's my transversal right here, okay? Two lines that are parallel, and I know they're parallel because I made these little arrows here. Two parallel lines cut by a transversal produce alternate interior angles. So that this angle here is congruent to this angle, as well as this angle here, not equal to this unless they're perpendicular, but this angle right here is going to equal to this angle here. So again, two lines that are parallel, okay, I'm telling you that they're parallel, cut by a transversal here, produce alternate interior angles. So that means that this angle inside, see, there's my parallel lines, inside the parallel lines, that's what the interior means. That angle inside is congruent to that angle here. Also, that angle here is congruent to that. Those are both alternate interior angles. So again, if this was, let's say, 100 degrees, then this would be 100 degrees. Because this is a line, remember lines, right? These are lines. They add up to be 180. So if that's 100, this is 80. And if that's 80, because it's an alternate interior angle with that, this is also 80 degrees. Then we have something called same side interior angles. Now, they're not alternate because alternate would be this angle and this angle, right? We're not talking about that. What we're talking about, the same side inside angle. So same side, this, and they're interior, meaning see how that's my parallel line and my parallel line? They're inside of the parallel lines. We call those same side interior angles. Now, same side interior angles are not congruent, whereas in our previous slide, alternate interior angles are congruent, meaning, remember, they're the same. They're the same angle. So these are not congruent because what they are, but they are what we call supplementary, which means that if this angle was 100 degrees, this would have to be 80. Okay? Now think back, right? Think back. If this was same side, they're on the same side, inside, same side interior. We call it same side interior angles. Those are supplementary. They add up to be 180. But think also that if this is 100, that's 100 because those are alternate interior angles, right? And if this is 80, so is that. And again, same side interior angles, these are the angles on the left. These angles on the left are also supplementary. Then we get to corresponding angles. Now, corresponding angles are kind of tricky because they actually correspond, meaning they're both going to be on the right side and they're both going to be on top of the angle. Or they're both going to be on the left side and they're both going to be below the angle. So for example, corresponding angles, meaning this angle on top here is congruent to this angle on top here. So if this is 100 degrees here, this is also 100 degrees. Remember, by the vertical angle theorem, right, that make those bow tie angles, that if this was 100, this also is 100, right? And again, this angle and this angle are alternate interior angles. But when you think of vertical angles, right, this is also equal to that value, which is 100, which makes these two corresponding, okay? So we've got a lot of different corresponding angles, but the trick to knowing about corresponding angles, because they are congruent, is that they correspond with each other. They're either both on the right side on top, or they're both on the right side on the bottom, or they're both on the left side on the top, or they're both on the left side on the bottom. So that's what you have to know, is that they're corresponding angles because they correspond and they're all congruent. Then we have something called alternate exterior. You know how we had alternate interior? That was this one and this one. Those are alternate, opposite, every other side. Alternate, and they're interior. Exterior ones are outside it. So think about this. If you have two parallel lines, the inside of the parallel lines is your interior, which means that everything on the outside is the exterior. So that means that this angle here is going to be the same as way over here. So if this is 100 degrees, this is 100 degrees down here. Likewise, we know this is a line, so that makes that 80, which makes that 80, okay? And then you can kind of fill all of this in, because if this is 80, this is 80, because those are vertical, right? And if that's 80, then this is 100, because that's a straight line, or vertical that way. If this is 100, that's 100, alternate interior angles. These are vertical, those are vertical. So, I mean, they all kind of work together, connect. And then we've got the last one, which is called same side exterior angles. These are not congruent unless the lines are perpendicular. Not only are they parallel, right, but then these would be perpendicular. And if that was the case, then these would be the same. Otherwise, if they're not perpendicular, what that means is they are supplementary because they add up to be 180. So if this was 100, that would be 80. So which angles were congruent? So the ones that were congruent, if you remember, we had alternate interior angles, we had corresponding angles, alternate exterior angles, and then the ones that were supplementary are the same side. So those are the same side ones, okay? So looking at this, these are our 8 angles. I want you to classify the pairs of angles. So take a minute and pause the video and try to do this yourself. So 1 and 6, so this angle and this angle. See how they're both, and this is assuming, people, that these are parallel lines. And then this is my transversal. All right, so 1 and 6, see how they both correspond and they're both on the left side and on top. So we call 1 and 6 corresponding angles, and they are congruent. Okay, so then we're looking at 4 and 6. So 4 is congruent to 2, and 2 is congruent to 7. but not congruent to 6. So we know they're not congruent. So that means that they are supplementary only, okay? Let's erase this. And then we've got 4 and 2. So we've got 2 congruent to 4 alternate interior angles, okay? And they are congruent. Those are congruent. These are congruent. These are supplementary, meaning they add up to be 180. 1 and 8, those are congruent. We call those vertical angles, right? Let me get rid of that one. 1 and 8 are congruent. They are vertical. And 5 and 1, and so that makes a line, right? And that means that they're supplementary, not congruent, supplementary. So some practice here. So what I would suggest you do, honestly, is to try to do some of these problems, because, you know, you're trying to find x, or whatever it is, looks like we're trying to find x, I think. And we know that you just kind of got to go through the motions. You've got parallel lines, you've got cut by a transversal, you've got another parallel line up here, cut by another transversal. So that's 115, that's 115, that's 115, that's 115, that's 115, nope, that's 115, that's 115. Because when you think, and all I did go actually was I did a vertical angle here, then I did alternate interior angles, I did vertical, and then these were actually corresponding, more vertical. And then I got to find x, which is here. So I'm going to go, well, what's 180 minus 115, right? Borrow. So I get 65. So this angle here is 65 degrees. X equals 65. Okay? You just have to work through these, okay? I'm trying to find x, which is here. And so working through this, I know these are parallel. So if those are parallel, let's see, that's 53. That's 53. 53, that's 53. That's 53. What's this? This, oh, another parallel line cut by a transversal, which only means these are parallel, though. You got to be careful. Not that. That's not parallel. So what's 180? Subtract 53, so I can get my other angle, right? So borrow 8, 7, 27, 1, 27. So this is 127. That's 127. That's 53. These are parallel. And then I've got no angles here other than that's x. So for this problem, do I even know? I know these are parallel. So if I've got parallel lines cut by a transversal, that means this is x here, but that's not going to tell me based on those angles because these are parallel. I don't have enough information for this, it looks like, other than, yeah, 53, that's 53, that's 127, that's 127. For this problem, I actually don't believe I have enough information because we've got these parallel lines here, which aren't parallel. And yeah, I have no value here. I can't say it's 53 because this side, this line here is not parallel to that. And I don't have any other information. So that is tricky, isn't it? Yeah, okay. All right, right on. Okay, next one. For this one, it looks like because all four of these lines are parallel, then that's 4x minus 25, which makes this 4x minus 25, which is the same thing right here. And because these are parallel, this angle and this angle are what we call corresponding. And so I can say 4x minus 25 is equal to, I think that says, I can't see that. Let me put my glasses on. 3x, that is right. 3x, add 10. I'm going to subtract 3x, I get x. I'm going to add 25 to both sides. And so this was 3x plus 10. 10 plus 25 is 35. So x is equal to 35. And I'm done. So unless I want to know what the angle measurements are, and then I would say 3 times 35, add 10. So 35 times 3 is 105, add 10. So we have 105 plus 10. which is 115. And that would be this angle. But they're not always, it depends what they're going to ask you. Are they going to ask you the angle, or are they going to ask you for, you know, the variable? So you have to decide, you know, what's happening with that. So with this slide right here, what I'm going to do, what I'm asking you here is I'm basically saying, what I'm basically saying here is try to find all the different angles. And so you would go through this and try to do that. And that's kind of cool. I'm going to make this a little bigger so I could see it better. And in doing that, let's see. Let's go with this, vertical angles. So we know that that's 57 equal. We also know that this is a line, right? And so find 180 minus 57. What is that? 123. 123. The only lines that are parallel are these two. Okay, so let me fix that. Let me show you what that looks like. This line here is parallel to this line here. That's it. So that means that I do have a transversal, right? But that's this angle here. So if this is 57, that's 57. Parallel lines cut by a transversal. If that's 81, that's 81. That's 81. Straight line, right? And so that's what, 99? So that's 99. And let's see. Actually, this is kind of cool. See if you see this. If that's 99, that's alternate interior angle with that. Those are both 99, but part of that is 57. So what's 99 minus 57? So that's 42. So that has to be 42. And you can check too that 57 plus 42 plus 81, like that, adds up to be 180. Okay. 57, 57, because those are vertical. And V definitely is not 81. V looks like it's 123. Oh, because look up here, you guys. Alternate exterior angles. Should have seen that coming. Okay. Alternate interior angles. So that's cool. All right. Good job. All right. Same. This one is a triangle. And what you need to remember is we do have parallel lines cut by transversal. Corresponding angles are congruent, which means that's equal to that. Okay, very tricky. Now, just take apart this triangle right here. And once you know that that's an isosceles triangle, this is 28, right? Take 180. So we're going to go 180, subtract 28. And if I do 180 minus 28, I get 152, which means that this angle plus this angle add up to be 152. But because they're equal, right? Because it's an isosceles triangle and angles opposite, congruent sides are congruent, we're going to take that and divide by 2. So I'm going to go 152 divided by 2, right? And get, what is that? 70, that's not right. 152 divided by 2, and I get 76. That's what I got. Okay, so that means that these two angles here are 76. Now, based on that information, if I have two parallel lines, right, cut by a transversal, another parallel line here and here, and then my transversal is this line, right there, okay, then this angle right here, 76, has to be the same angle as this one here. So they're both 76. Likewise, so is this. Cool. Oh, and how do I find Z? The way I find Z is that's a straight line, right? So what's 180 minus 76? Borrow 4701. 104. Okay? Easy. So today, your homework is 2.1.1 and 2.1.2. And check your answers. Make sure that you do that. Thanks for watching. And I will see you in class next time. Hope this helped.